To all of you who are here now, thank you very much for coming. This is the first virtual iteration of the WHIPgroup Tech Entrepreneur Meetup. Obviously, it's not the way we'd like to be meeting, but given the circumstances, we thought it was still just a great opportunity to get together and to continue our discussion of tech-centered topics while we're in this state of relative quarantining. So for those of you for whom this is the first time at our meetup, we meet the third Tuesday of every month. And we like to bring in an external speaker and talk about kind of a tech-related topic to facilitate technological conversations in Stanford and the greater Fairfield County area. My name is Ben Lewers. I work for the Whitmire IP Group, who hosts this meetup. We are a patent and trademark law firm based in Stamford, Connecticut. So the topic this month is hardware in a hurry, designing, developing, and deploying on dime. With advances in technology, it's easier than ever before to get new hardware products to market quickly and on a shoestring budget. Tonight, we're really pleased to have as our speaker, serial entrepreneur and project engineer, Nick Johnson. Nick has held executive positions in several tech startups and as a founder of Proto Ventures, and he has helped bring tech products to market for over 20 companies. The last few months, he's held the role of CTO at Intake, a company that aims to put lab quality health measurements in every home. And as you saw in our description of tonight's meetup, tonight Nick will explain how to speed product development using on-demand electronics manufacturing, attract early adopters who'll be willing to spend money on products that may not be final yet fulfill a need, ship multiple products and earn revenue while iterating your products, and scaling up vertical manufacturing without having to raise any capital. So on behalf of our group, Nick, we want to welcome you and thank you for being with us tonight. And so at this time, I'll turn it over to you. Oh, Nick, sorry, we can't hear you. Despite our earlier test. Nope, not now either.
Now.
Oh.
Check.
Yes, we can hear you now. Or I can hear you, yes.
Thanks, Ben. Quite the intro there. All right, are we seeing this?
Yes.
Okay, yeah, I got a nod from you. You're muted. All right, awesome. Hey everybody, I'm Nick. I think that intro was good enough as to what I do and where I'm coming from. I make hardware products. I have for a few years now, all in electronics, lots of IoT, lots of consumer devices, and from where I started to where I am now, it's gotten much faster and easier to do. And one thing I've found is that while I think everybody, and I could pose this to you guys, while people spend most of their money on tangible physical goods, people don't seem to realize how much easier they are to make now. So it's one of the things I like to talk about because the process has gone from years, right? As you can imagine, maybe making these headphones to months, and it's gone from hundreds of thousands of dollars up front to maybe $1,000 up front, and that's even in an extreme case. So that's the intro. So let me kind of get into some of the particulars as to how this works. Okay, so let's start at how were products made, right? Like let's talk back 10 years. If you were to try and make a new product, specifically electronics, that's my domain, how would you do it? Okay, well, I'd say the process is a little bit simplified, but it's broken down into this kind of product cycle where you come up with an idea, that you think is good, that's going to work in the market. It's going to sell. It fulfills a need to some degree, but that's kind of subjective. And you decide, okay, we're going to build this because it's going to make a lot of money. That's usually kind of the driving factor. And then the next step is you say, okay, well, now we need to build it. How do we build it? Well, we need to raise a bunch of money. That's always the next step. And that's what everybody I ask who wants to build something new, hey, what do you think step one is? They always say, well, I'll go raise a ton of money and then hire people, right? So this is how it's been done for a really long time. There's a reason people think that. So you fund it, right? Maybe from a private investor, maybe from friends and family, maybe from another business. And then you develop it. You take that money, you funnel that money right back into people and resources, and you develop it usually over the course of maybe 2 years is a pretty reasonable development cycle for electronics. And so within this 2 years, the caveat is you're just building that one thing from that idea. So the idea from 2 years ago that you've just finished, let's say after a period of 2 years, it's still the same idea. It hasn't changed very much, right? And if it does change, that development cycle can quickly kind of spiral out of control and become 5 years, you run out of money. But let's just say you're a successful product. 2 years in, you're still working on that idea from 2 years ago. Then you go to manufacturing. That might be another full year of manufacturing, getting the product in-house, distributing it yourself to finally sell it and get it to people. So from the time of an idea to the time of sales is about 3 years. And now there's a whole litany of problems that can happen in that time frame, right? The markets can change and people don't want it anymore. The technology changes and there's something already better out there that you're worse than. Your development team breaks down. Your funding pipeline breaks down. Your stakeholders want something different. You can't keep up with demand. All these things make this model bad. So this model has changed. This was 10 years ago. Now let's talk about, I don't know, 5 years ago, 2 years ago even. How are products made? How are products made now? Okay. So people learn from their mistakes and they realize, okay, we can't just come up with an idea that we think is good and if you build it, they will come kind of thing. We need to identify a need and we need to make sure that that need is persistent, that it'll last more than the time that we're developing and that it's pertinent. Somebody really needs this. They don't just want it. And so typically the way that you make a new product now is you find that need, you find that problem, right? Every pitch deck starts with the problem solution. That's for a good reason. It needs to be a persistent problem. Then the next step is you come up with a solution to that problem and you typically build a prototype. And in the hardware world, the prototype is what you think it is, right? Circuit boards and 3D printing and even cardboard, whatever works for you. And then you validate it. Then you see, okay, is this prototype something that people can wrap their heads around, that people can get on board with, and you validate and fund it. And in the last few years, you've seen things like crowdfunding really pop up. ICOs is another form of crowdfunding have popped up. Pre-sales are getting super popular, especially now, as a way to fund your business, right? And so that whole process of, okay, we've identified a real problem that has a real solution, come up with an idea to solve it, to the point where you validated it, typically around 1 year, right? So now at this point, you're kind of ready to sell. And so you've instead of waiting 3 years to go and sell, after one, you are. So you make sure that problem still exists. And if it doesn't, you can loop back through again and make sure that it does, right? So this is a kind of a fail-safe, and this is what most people do. So once you've gotten to that point, you realize that it's validated, people want it. Maybe you get pre-sales or you get letters of intent from big organizations, or you know from traction, maybe you built a community of users or something like that people want it, then you can fund it. It's easy to go to a venture capitalist and say, hey, we have pre-orders, give us some cash so we can do this. That's usually the way it works, right? So then the next part is the same as the last 10 years. Then it's this build, manufacture, and sell process. And that part hasn't really changed all that much. And so that can carry on for a long time. That can be 2 years, and you're still running into that same problem, where by the end of that cycle, you might have missed the boat, or you might have wanted to make some changes, right? And so although this is working right now, I mean, you have your iPhone, you have your TV, your 3D printer, what have you, it's getting faster and it's getting better and it's getting more accessible, right? All these things kind of take a lot of resources. They're very resource heavy and they tend to fail a lot. And so how do you make these a little less fail-proof? This is the way that I've been building products for the past probably 4 or 5 years. And it's a little bit of a confusing map out here, but I'll make it make sense. Okay, so the very first thing that you do, and this is kind of borrowing from design thinking, if anyone's already familiar with that methodology, in that you start the way that people have been starting, right? You look for a need, then you prototype, right? You make something that people can wrap their heads around. Then you validate it and you fund it, right? So it's similar to the way that it's been done the past 5-10 years. But then you go straight to selling it. And the reason that hasn't been all that accessible in the past is manufacturing has always been a must if you want to cater to a large audience. But now, because fulfillment is so accessible, vertical manufacturing, 3D printing is so accessible, you can make small batches and sell those to a really targeted audience as a form of a lesser product. And so I guess what you're doing here is maybe to get to that product, that need that you had at the beginning, the solution you came up with to fill that need, that might still take 4 or 5 years or however long it might have taken before to actually get to that product. But you can do 4, 5, 6 iterations of smaller, lesser, kind of not as good products in between that you can sell. And the sales from those products, that revenue can kind of fuel the whole process. And so typically what happens here is, I'll give you a practical example, a need. So one thing that we did recently was we were working on a product. Actually, I'll talk about intake. We're working on this product, and it clips onto the side of a toilet, and it measures pee, measures your pee, sends your biometric data to the cloud, and you can make sure you're healthy all the time, right? Constantly track it. And so what we've done, and this is version 3 here. What we did first was we just built something that tests pee, right? It doesn't stick onto a toilet. It doesn't have a motor in it that pulls the water out, and it wasn't fancy. It was just kind of the modular piece. And what we did was we went to, we took that, we built that prototype. We brought it to a bunch of doctors, and we said, hey, is it useful to you to have this device that you can give to your patients so that they can go and measure their own pee and just report the data back to you? Maybe for people with cirrhosis or heart failure or high blood pressure, hypertension. And they said, yeah, sure, let's give it a shot. And so the first few, we kind of negotiated deals and gave them away, got some validation. And from that, we got some data. We used that data to go ahead and go to other doctors, get some letters of intent. And because we had people who wanted to buy it, we were able to do pre-orders. So that's how we funded it. And from that funding, we just sold them directly. We used some of that money to make sure that we were covered, FCC, FDA, and then we sold them. So that was the first batch. Come back to the need. We looked at the need. Okay, so people don't like peeing on a stick or peeing on a sensor. So we decided, okay, well, now let's prototype a way to just pull it directly out of the toilet. And so we did that. We sent those out to doctors. We validated, funded it. We sold them again. And now we're on version 3. So that's how we've done that whole process. And each time in the process, we've built these in-house vertically. If we ever need something nicer, there's services that you can go to that you can just order your parts from, and they're cheap and they're accessible. They ship them right to your door. We've done this all from inside of our houses. We're a completely distributed team. And so now the part that usually takes a really long time is this manufacturing part at the end here. That's kind of optional now. I mean, until you go to scale, you don't really need to go to manufacturing. And what's great about this is the whole time through, as you make changes to your, let's say, plastics or your electronics, you can just keep quoting. And as you quote with these distributors and suppliers, you kind of gain rapport with them. And so by the time you actually do go to manufacturing, there's a lot less friction than if you were to say, okay, we're ready to go. You can just kind of go straight to market, which is really nice. And so that's been working really well for us. So let me get into some of the specifics now. Because how is this possible? I think this methodology that I've been using, that I've seen other people using, borrows a lot from software. Now, if you look at software, there's a reason why most startups go that route, right? It's just really easy. You can build your product, you can test it in-house. Then you can do this magical thing called beta, where you can give out a really crappy, not finished product. You can even have people pay for it. And then once you get to the point where you're comfortable with the liability of putting this out there on the market. Even if it is crappy, you release it. And then once it's released, it's out there. It's kind of still a beta. Google's guilty of this. They put out really buggy products all the time and just wait for people to complain about them. Then you go back to building the next features. You test them, you beta it, you do it again, right? And so it's kind of evolving over time. You just keep in smaller, discrete pieces, chunks, deciding what is it that people actually need more than just what they want. And because of that, you end up building a better product. And on the other side is if you were to, let's say, do the old way and build software over the course of 1 or 2 years, you'd end up building a lot of features that people would probably not even not benefit from, but dislike, things that get in the way just because you made some assumptions. So this helps you build better software and helps you test your own assumptions at the same time, right? Your stakeholders become part of your product development process, part of your company. Okay, so what is software leveraging here that makes it so easy, so much better to create? And so the first thing is the low cost of scalability. If you build one, you can build as many as you want, right? As long as you take care of your technology stack and you use good principles, which are easy enough to learn these days, there's no cost. There's no cost to get to a lot of people, right? So that's keep these in mind. By the way, I'm gonna address these when we get to hardware. But low cost scalability, there's no manufacturing cost. So that's one thing. Okay, so if you think about it now, how would you overcome that in the hardware world? Okay, so establish code bases. If you wanted to build LinkedIn 10 years ago, it would be horrible. It would be an exercise in pulling your hair out and banging your head against the wall, and eventually you'd get it done. But there were a lot of things 10 years ago that don't exist now. If you wanted to build LinkedIn today, I've seen people just pull in a WordPress theme that someone else has written, 2 or 3 plugins, and functionally it's almost the same as LinkedIn. And this is somebody who's never even coded before. You can no code LinkedIn these days. So building on established code that's already been tested, that's already been built, that's already been reviewed through that whole process of going to beta, building, testing, reviewing, you don't have to start from square one anymore. You don't have to reinvent the wheel. So it's modular almost. You're kind of just clicking pieces together. And that's evidenced by APIs and API companies that are getting really popular now. Maybe some of you have dabbled or heard of If This Then That and Zapier, 2 separate platforms that let you take, let's say, Google's API and hook it into Facebook's API, so that when you get an email in Gmail, it will go on Facebook and post a post for you, right? You can automate everything in the background because everything's connected with APIs. There's all of these services that you can just leverage for free by clicking into them. So everything's modular in software. Not everything, but most of it. Okay, now ease of distribution. It's kind of easy to get software out there these days because you click one button and you download it. And even better is web apps. They exist right in your browser. People spend most of their time on the internet in a browser. And so all you have to do is just put in a URL like you're used to doing, and you're at the software, and now you can start spending your money, right? It's very easy to get people using it. Now, staying on it, that's another thing, but that's maybe a topic for another day. So distribution, another problem that, okay, how could we solve that with in the hardware world? Think about that. And then it's point of sale. It's digital. It's a couple lines of code, right? At most, maybe a couple megabytes, and you click it and you own it, right? And most of the time, especially with web apps, all you're buying is a license. So they're just associating your account with the ability to use it. So, you're spending money for maybe, 64 bits, and there you go. That's how you transfer ownership. So that's really easy. There's no inventory, okay? So that's what software is leveraging to do these things. And so now I'm going to show you how hardware, maybe not yet, how hardware doesn't leverage these things and how it can. Okay, so first, hardware, why is it challenging? Let's look at scalability. So everybody knows the upfront cost of hardware manufacturing is super high, let's say you wanted to make a new microphone, right? Tooling for just the casing on the outside alone is probably upwards of $100,000 upfront. And that's maybe, that's going to make 100,000 units for you, but sure, that'll get you pretty far, but it's really expensive. Okay. So it's kind of hard to circumvent that. That's just something that you need to account for when you're building new hardware. And so you need to raise money. That's bottom line. That's kind of the only way you can get around that, is to raise money or partner. But partnering it's very rare that works out. Okay, so that's scalability. That's an issue. We'll figure out how to deal with that in a minute. Okay, complexity. See, most of the time with hardware, you're building from scratch because your new idea is physical, and you need to take into account, in my trade, electronics. Right, their power supplies need to be built from scratch. Every power supply needs a certain voltage and needs a certain amount of current. It's very unique to what you're doing specifically. There's physics involved with all this that you have to take into account. So there's a lot of complexity involved, and it's multidisciplinary. Whereas software is getting a little bit easier. Right, if you look at front end, back end, you can do the whole thing in JavaScript nowadays. There's not really a good translation between an electronics engineer, a firmware engineer, and a mechanical engineer. They're just three separate trades. And so that needs to be accounted for. You have to build big teams or big skill sets. And so it gets complex. Okay. Now, distribution. A lot of people fret over this. You have to get the devices or the end product to people. And so here's the typical way you do it, right? You create your product. It's good. It's good. You go to manufacturing. They manufacture it. And they start making them by the hundreds of thousands, and they put them on giant pallets, and they ship them to your fulfillment center or to your to the dock where they ship it to your fulfillment center. And now your fulfillment center has to take in your orders and ship it, and there's a markup on that, and it starts eating away at your margins. You start losing product. It's a complete nightmare, right? It's very challenging. And so, even if you've gotten to the point where your product's done, ready to go, and you start scaling, distribution could get you. That could pull you under. So that's another challenge in hardware. And finally, liability. So let's say you hit the point where you're distributing, okay, now you're holding inventory, and something like COVID happens, and now you're just sitting on a bunch of inventory you can't move. That's just money that's tied up, right? So how do you get around that, right? You're sitting on something that eventually you might even have to sell at a loss just to get out. And so these are a lot of things that cause hardware companies to fail and cause people to not even start. So I'll show you how we kind of circumvent these things using modern tools. Okay, so here's how we make hardware more like software. So the scalability issue, it's hard to get up and running because manufacturing costs are so high. Vertical manufacturing in small batches is working, and it's more and more accepted. So what people are doing is they're creating really stripped down versions of products, and they're using 3D printing or 3D printed molds to create really cheap small runs of products. And now you're not going to get as much on the revenue side as you would had you gone big, but you get your revenues faster, and it ties into branding. So these people who are getting your products, even though they're unfinished, they're in early. They're fans. They either like it or they don't. And if they like it, they're going to buy the next one. They're going to buy the next one. The same reason when people bought the iPhone 1, the same people with iPhone 1 or the people with iPhone 10, 11, is because every time they made a new product, they said, okay, the last one was pretty good. It wasn't exactly what I wanted, but I trust them that they're going to make the next one even better, that they're going to do it because nobody else is doing it, right? They're catering to me. They're solving my problems. And so doing this is going to get you to sustainability pretty quickly, and it does so over and over again. So that's how we deal with scalability. You don't pay a lot up front. You pay a little bit more per unit, but as you get into higher batches, larger batches and higher amounts of product, that's when you can go to large scale manufacturing and start saving money, right? Fix your needs as they come up. So that's how we deal with that, make it more like software. Now, reducing complexity. Okay, so this is the part that I think most people just don't know about because it's kind of esoteric, is that the same way that there's APIs for software, there's modules now for hardware. This is electronic specific, but it also works for other disciplines too. But I'm going to get to a case study in a little bit where we used a module and explain how that went down. But you can build off of the same way people are making proven software that you can just pick it up and trust it because so many people have used it, so many people have reviewed it. You know, you look at all the commits on GitHub, and so many people have just over time validated it. There are electronics packages that are these little boards. Do I have any? Here's one. It's like a little Wi-Fi chip. And it's been used so many times that, and it's by so many people that it's just trusted and it works. And it's also, I don't know if you can see this on there, but it's also FCC certified. So you can use this module to connect your product to the internet. This thing specifically is, I think, $1.50 now. And you can build your whole product around it and go to market without paying $10,000 to the FCC to test it as an intentional radiator because it's already been tested. And so you can do that with a lot of things, with your power supplies, with your batteries. And so now, the same way that software was modular, you're pulling APIs together and just connecting them to make something work, right? You're just using the logic in your head to put that logic to work for you. You can do that with hardware. It's not as easy as with software, but you can do it very easily nowadays. So that reduces the complexity. Now, improving distribution. So I think Amazon is the best thing to say here. A lot of the companies I've been working with, especially over the past year, building a lot of products for small companies, are just going to Amazon because it's so effortless to just build as much as you think you need to sell. Gauge your community that you've been testing it with to make sure you have as much as they want. And you just send it to Amazon and then you forget about it. And then you just go back to building, right? They take care of a lot of your company. A lot of your marketing. Maybe it's a topic for another day, but if you were to spend, let's say 33% of your budget, which is a reasonable amount, on marketing, that's how much you're spending on Amazon. And if you're the only, if you truly are solving a unique problem and you're the only one in that lane, you're going to sell your product just off of search volume alone. So distribution has gotten really easy with that. And if you're not comfortable with Amazon, you don't want to do that. There's also cheap and free e-commerce solutions, so you can do that. You have to generate your own traffic, but that's also really easy to do, scalable. And then there's also fulfillment companies that are trying to compete with Amazon. I've seen a lot of those popping up too, especially now after COVID, because people want to sell their physical goods. That's what other people spend their money on. It's just the fastest, easiest way to do that. So that's improving too. And then finally, liability. In the latter way, the former way, the original way of building products, you go through that 3-year product development phase. You generate a bunch of stuff in manufacturing, and then you sell it all at once, and you have a huge amount of inventory. And if it doesn't all sell, you're stuck with it. And it's this kind of a balancing act between funneling money into sales to try and get it off the shelves, and not moving it, right? And decreasing your spend because it's not selling. And it's a nightmare place to be. But so now, if you do sell in these smaller batches, one of the great benefits is you can gauge you have community-driven demand. You can gauge your demand with data, with metrics. So let's say this is your third time around, and the first thing sold this much, the second thing sold this much. You know what the third is going to sell probably. So you can really kind of make the exact amount that you want. I'll get into that in a case study. So there's a lot to digest, but here we go. This is going to make it more tangible. So Rep 1, this is a product I worked on 2016 it's actually going to market right now, this final version of it. And what it does is it is a powerlifting device that you bring into a gym, and it has a pulley that hooks onto the barbell, and it just measures the speed of the bar, which is a very useful metric. It's called velocity. You can use it to calculate power in weightlifting. And it's a metric that the pros use, professional athletes use it. And so this one can also measure the angle that it's being pulled at, so you can also measure bar path. You can get very technical, but that's not how it started out. So we took the original idea of look at the problem. There is no affordable, accessible way, excuse me, to take accurate data on your lifts when you're working out. There's ways that are accessible to professional athletes and professional teams, but not the average person. Okay, so we decided there's a market for that, right? There's enough people lifting, trying to get to a professional level on their own, Googling, hiring coaches, whatever it is, that there's a market here. So we thought of a solution. You know, we kind of looked at how the products in the market that were selling for $10,000-$20,000 each were doing it. We kind of came up with our own technical solutions that we figured were achievable in the short term. Okay, and so what we did after that was we took our ideas and we went to the market as you do nowadays, and we asked people, influencers and professional powerlifters, people representative of these communities, if this would be interesting to you. And they said yes. So we built a little prototype. I think that's next. Okay. We went back to them. We asked them if this is what they were looking for. They said yes. We did our pre-sales. We did some crowdfunding, and then we brought it to market. Okay. And so this prototyping, this whole process, by the way, start to finish, from problem to crowd sale, cost us under $1,000 total, and a little under 6 months. And so it sounds a little surprising, right? And so let's get into how did that prototyping, how did that product development phase cost so little? So here's how we did it. We started off, let me see if I can get my pointer going here. Pointer. All right. Started off here with the chip. We decided, okay, we know how this thing's going to work. We wanted to connect to a phone with Bluetooth. Oh, so let me take a step back to MVP. We decided to make the most stripped down version of this possible, to make it really accessible to somebody so that they can carry it in their pocket, and it would just do the very bare minimum and measure some metrics on a barbell's motion. Okay, so the first thing we did was we decided, okay, let's get a microcontroller that can connect via Bluetooth to a smartphone. And so, did a little searching. We found one of those modules, very much like this one, that can do all those things. Right? It's already validated. It's already FCC certified, and you can buy them by the thousand at maybe $3. Right? So, okay, we have the core, the brain of our device. Now let's look at our per unit cost. It's really, really cheap right now. So let's move a step further into this lane. We need to start doing some real designing, some real engineering. And so on the plastic side, on the body of this, you know, typically you need something like SolidWorks or NX or something like that. And you look at the licenses for those things, and $2,000, $3,000, $10,000. Usually that's a huge barrier to entry. And if you look here where we're electronics and EDA like Altium, again, the license I think is like $3,000 per year. So very, very inaccessible a couple of years ago. But nowadays, there's free software for both of these, and that's what we use. We use Fusion 360 up top to do our 3D modeling. It's just a totally professional mechanical engineering environment, 100% free for startups and for makers. So we use that. Now on the bottom, we use something called Easy EDA, which lets you design electronics in your browser for free. And when you're done designing the electronics, you can just click order, and they'll send you your PCB boards in the mail. So that's what we did. If you move on to the next stage here, right now we're at, remember, $3 per unit, because that's what we're using for our chip. And so now we press print out of Easy EDA and we get our boards in the mail. I think each of those cost about $5 a piece without the chip on them. So now we're at $8 a unit. So we make 10 units, including shipping. It's about $100. Okay, and so $100. We've got 10 units, and those come in the mail. So then we go back to mechanical engineering, where we just design stuff in our free software. We decided, okay, let's see how we can manufacture these. Let's just print it out. So we looked at 3D printing services, and they were a little expensive. So what we did was we bought a printer, the Creality Ender 3, which cost us $170. We ended up here. So for $170, and the spool here of plastic is $20. Each spool could make us 8 units. And so 20 divided by 8, it's about $2 and change. That's how much each unit cost in plastic. So now we're at, what did I say? It was something like 10 bucks a unit plus another 250. We're at $12.50 a unit. We've spent just a couple $100 now. Now this is where we spent most of our money. So now we have all our plastics in hand. We have all of our electronics in hand. We actually did a few rounds of both because we had the agility to do so. And once we got something working, we brought it all in-house here to our assembly, where we actually just figured, hey, we've got enough budget to pay people to put these things together at scale. So that's what we did. Paid people 15 bucks an hour to put our units together. Then we went back to the people we crowdsourced to. We gave them the units that they wanted, crowdfunded to. We gave them the units that they ordered. We ran another pre-order just to kind of gauge if more people wanted it. They did. We went back to square one. That's made all of our units and we sent them out. All in all, I think it cost us like $800 and we shipped out 550 units. We sold them each for $300. So it was not very much money up front, and we made a lot of money on the other side, in revenues. And the great thing about that is what we shipped out then was not Rep 1. It was not what I showed you. It was a much crappier version of Rep 1. But we sold it nonetheless. And once that was done, we went, that was called Open Barbell V1. Once we were done with that, we made V2. We did the same process. It was a little bit less crappy. Then we went to V3. We did the same process. It was a little bit less crappy than that. And now Rep 1 is what we initially wanted to make. And we've turned one product, that one idea, into 4. And each one of them sold separately. So I guess the idea is don't make the iPhone 10, make the iPhone 1. So that's the whole process. I think I reiterated things enough that it's time to conclude. But some of the tips, if you were to try and get into this yourself, is build off of these platforms that are already there, like these cheap modules, code platforms like Arduino, things like that are very accessible, easy to get started with, and you can just use somebody else's work to get up and running quickly. Manufacture vertically. You can buy 3D printers and make a small factory in your house for under $500. You can keep them running all day and all night making products. So even if something you're building isn't electronics, if it's just a piece of plastic, like it's some kind of new kitchenware or a bowl or something like that, you can do that in your house nonstop all the time, day and night. And again, the plastic itself, the spools, these things are 20 bucks a piece, just for 2 pounds of it, which is a lot. Selling early. Now, I think people have a much higher tolerance for prototype beta hardware these days, right? The same way people have higher tolerance for beta software. I mean, how many times are you using Google stuff and it just craps out and you're just frustrated, but it's like, hey, whatever, I got it for free. I got it for cheap. I got it early. I was an early adopter. People are the same way otherwise. And you'd be surprised. I think this is a big barrier for people is they don't want to sell something that's not perfect, but you sell it to the right people, they're going to buy the perfect one. They're going to stick around for it because you fulfilled their need, at least in the short term. Using this beta, and I really love this whole terminology and this whole idea of beta is empowering people to be your testers. There's a mutual understanding that what you're using is not perfect. It's kind of what I was just touching on with selling early, but what you're using is not perfect, but your help is going to help us make it better. And I think there's some subtle psychology to that, in that if you are improving someone else's product, you have some stake in it. You have got some skin in the game, and you're going to want to buy the final thing, right? Your beta testers are probably always going to buy it if they enjoyed the beta. So if you can find the right people to join your beta to begin with, maybe somebody in your niche, if you have a very niche-driven business, they're going to buy it. So it's a good way to get customers by starting small. Turning one product into many. If you have an idea and it sounds like it's too big to go for, and that's what's holding you up, think of the smallest, really just the crappiest version of that product that somebody would actually buy, and you'd be surprised. I mean, if you think, okay, no one's going to buy, you know, if I'm making this automatic toilet paper dispenser for COVID or whatever, what if I just made it rip one sheet off at a time or something like that? And you'd be surprised if you went and asked people, would they want that? You'd be surprised that people would say yes, and you can get that product out much, much earlier than you thought you would. Use those revenues to build what you really want. Using free and cloud software, this has been, without this, I wouldn't be able to do any of the products that I do. You can not only build on any computer in any environment, you can move around, be really mobile. You can also share what you're working on with any team members. So if you go to hire someone on Upwork because you've hit a point where you might have a technical snag, they can come in, work on it, and leave, and everything's still intact. There's version control built into all this stuff. So it's a really easy way to scale up quickly. Leveraging community-built services. One specifically is WooCommerce for WordPress and WordPress in general, and things like that, where there's huge communities of people working together to make the most efficient free stuff you can use. That's typically a good way to go. Just to source whatever you need in the in-between. You don't have to spend a lot of money on stuff. I don't discourage spending money on stuff, but this is just, you know, if your barrier to entry is cost, this is going to solve that problem. Using fulfillment, again, if you were to ask yourself, what do you spend most of your money on, or if you were to check your bank account or your credit card, I guarantee you 90% of it is going to be physical goods, right? And so even though software is easier to get out there, hardware is really what sells. And so if you can use fulfillment services like FBA from Amazon or any of the other fulfillment services that are up and coming now, it's going to take that off your plate. You don't have to be a fulfillment business anymore. You can just be a product developer, which is what I do. And then exploring all of your hardware APIs. In quotes there, hardware APIs is what I'm referring to is using those modules, using all that modular stuff that's already been built and just clicking it together. Arduino is a good example of that. There's something else new called M5 Stack that just lets you kind of modularly clip your prototypes together, and you can even sell them that way. It's really nice. And so I guess all in all, building hardware these days it's not a breeze. I don't think it ever will be. Maybe in the next 10 years, I'll give another one of these on how I'm doing it in my sleep. But it's much cheaper and faster than it ever used to be. That's it. Thanks for listening.
Thank you, Nick. That was outstanding. We really appreciated the presentation. Like our in-person meetup, I want to open it up for questions, and I think the best way to do that is if you open up your participant tab on the right-hand side of your screen, there is an option at the bottom to raise your hand. And so if you have a question, we'll leave it open for just a bit. If you click on the hand raising icon, then I can unmute you, and then we can send some questions to Nick. If anyone has questions, give you just a minute to find that icon. And while people are doing that, Nick, I have a question. So on Rep 1, when you were building that, did you pre-plan out what you thought there were going to be like 4 iterations, or did you not know the number, you just stripped it down as much as you could and built from there?
The latter, totally. Yeah, our only goal was to make something accessible to us, and I think part of that is looking at your skill set and what you can do right now. And I think a good example of that is NerdWallet. I don't know if are you familiar with NerdWallet? They actually started as just an Excel spreadsheet because that's all the guy could do was build an Excel spreadsheet. So he did that and he put it out there. It resonated with people. He started selling it. Once he got revenues from that, he hired a developer, and here we are. So I think just finding the worst working thing that you can make yourself and trying to sell it, see if it sells. And if it doesn't, you'll learn a lot from that. So I think it's all, try it and see what sticks.
Okay. And I have a question here from Bill B. I'm going to unmute him here.
Hi, Nick. Just had a question to build on what you said before about dealing with vendors and how you said, you can kind of develop your relationship with them a little bit by quoting with them often and sort of becoming a familiar face with them. I was wondering, what other tips you might have for building a relationship with potential vendors for parts. Being a small startup, I can see a lot of these places maybe not taking you too seriously at first, and I wasn't sure if you had any other tips to sort of put yourself out there and show that you're a serious party.
Yeah. Are you looking overseas specifically? That might change my answer.
It's more of a hypothetical.
Okay. Yeah, sure. First and foremost, most of these businesses, let's say we're getting plastics or you need boards built, their costs change over time just because it's so competitive, right? And so a lot of the ways that they get their business now is by putting out these quote tools where you can just go and get quoted on the fly. And usually they try and underquote you there just so that they can get you on a call. And so what I always recommend to everybody is just set a day aside and go fill out every quote tool you can, because in the background, what happens is they put this quote out and now they're like, oh, well, now we have to call this guy and really reel him in. And so they're paying salespeople to do that. They'll come and contact you and just take all the calls, right? And just right up front, just be like, hey, I've only got 5 minutes, and just find out what it is that's unique about their value proposition. Because a lot of them now, they know that if you filled out one quote tool, you filled out a lot. So they might just say, hey, we'll get the lowest pricing, or we'll have the best shipping, or we'll match any price you get, or if one of our suppliers or our personal vendors falls through, we'll go find another one. So that's one easy way to do it. And then there are companies like in the electronic space that will partner with startups just so that they can win on volume deals. Arrow specifically is one of those. They work a lot with Indiegogo companies where if you finish your electronics, you can go to them with your bill of materials and say, hey, Arrow, can you subsidize this at all? And they might take 20% off, source everything for you, take over your supply chain, just so at the end of the day, they might edge in a few components that someone's paying them to use, and they get a kickback from that. So there are through the partnerships and through those quoting tools, you can start that early, and through that whole process, just keep kind of pinging these people, right? They'll call you back, you call them back, and by the time you're actually ready to go to full scale, you just know them and they know you. Yeah, hope that helps.
Yeah, that's great. It's a good answer. I just had one question to go back to your domestic versus foreign vendors. Are there any main differences that you've noticed dealing with domestic as opposed to, say, Chinese vendors?
Yeah. If you were to go to China, I would highly recommend using a sourcing agent. Actually, for Open Barbell version 2, we did go straight. We went on Alibaba. We put out a request for quote for a bunch of just for some plastic parts. We got our quotes back. We picked something in the middle. We negotiated back and forth with a bunch of guys. All said and done, we got our parts, but we got them after a month of negotiating, a month of changes, and they sent us parts that were bad, and they had to send us more. So we went through about a month and a half of shipping. All in all, we lost a lot of time, and it wasn't worth it. So what I would recommend is either go vertical to begin with, which is really my number one. Go with somebody in America like Xometry. What they'll do is they have overseas partners that they've vetted, and they'll try and price match in anything. They have guys that are literally in a garage in Shenzhen, and then they've got Flextronics, who's making the Xbox. They've got all those guys kind of in their speed dial. So that's one way to do it. And then if you want to go really cheap, what I would recommend is just to jump on Upwork and put out a request for a sourcing agent. And that's somebody who speaks English, has feet on the ground in China, probably in Shenzhen, and they have relationships with these manufacturers, and they can map out the whole thing for you, right? Like they can even split up your electronics from your plastics so that nobody owns the whole thing if you're afraid, for IP's sake of your thing just being reproduced. That's what I would do if I went overseas. Yeah.
Okay, thank you.
Yeah, absolutely.
All right. I'm not seeing any more raised hands at this time. If anyone is having trouble raising their hand and wants to ask a question, now's your chance. If you want to unmute yourself. But yeah, if nothing comes up, Nick, we really appreciate you taking the time tonight and being our first on this kind of virtual. Oh, good. Okay, we got one more hand here.
Hi, Nick. This is Raghu. Thanks for the presentation. It was nice. Just curious about the. I think I missed the part where you say examples of those services that does the microcontroller work. Do you have examples of any software or any company?
Yeah, sure. I think you kicked that a little bit at the end there. But if you were to do it yourself, specific, I would go with Arduino. That's the most popular. It's a programming environment for microcontrollers. And what's great about it is it's not a super advanced piece of software, but there's just decades of pre-built libraries. And so let's say you wanted to build a distance sensor, maybe to clip onto the bottom of a drone, right? Just so you can always measure its altitude. There's literally two parts you can buy. You can buy this sensor, right? There's somebody who's selling it already in that Arduino infrastructure, and you can buy the microcontroller. And all you have to do is click them together, plug them into your computer, download somebody's code example, make sure it runs and does what you want it to do. You might have to tweak it a little bit, but it's going to work probably within a day or two. And so that's the simplest way to do it. Once you get more advanced and you start doing, when speed becomes really important, and you really need to start tweaking things, you can get kind of lower level into firmware. There's another service called Mbed, just MBED, which is very much like Arduino, but a little bit more advanced, a little bit harder to get going with. But if you wanted to start building something, I would just start looking at Arduino. It's the fastest, easiest way to do it for sure.
Thank you. Can you spell that one again for me?
Sure. Yeah. Arduino is ARDUINO. And the other one is Mbed, just MBED. Yep.
Thanks a lot.
All right. Well, again, thank you, Nick, for your time. For the logistics standpoint, my apologies to anyone who had trouble getting into the room. Thanks for bearing with us in this first week. We'll try and figure out any glitches for our next meetup, which will be the third Tuesday in May. So thank you again, Nick, and to everyone. Stay healthy and safe, and we look forward to seeing you all next month. Thanks again.
Awesome. Thanks, everybody. Thanks, Ben. Have a good one.